All right, so welcome to all the NEET aspirants, welcome to all the future doctors, and I am your very own Dr. Shankar Tripathi, and I am here to discuss today the concept of the screw gauge, right? So, guys, in the last session we have studied about. In the last session we have studied about this, vernier caliper, which is also a device which is also a device for this measurement of the length. Okay. Okay, so in the last session, guys, what we have spoken about. So before I start with this session, so I am your Dr. Shankar Tripathi, and you are at your very own channel, NEET Success Simplified, and we are here to help you in your NEET preparation for NEET 2024. Okay, so these are my brief credentials. I'm hoping that you have seen my previous videos also, so I'm not taking much time here. So let's come to the point. So in the last session, guys, we have spoken about this. In the last session, we have spoken about the vernier caliper, right? We have talked about the vernier caliper. We have spoken about this vernier caliper, and we have seen that how we can take measurements from this very device of vernier caliper, right? And how it is an improvement to the meter scale. So ultimately, in the last session, what was the conclusion? The conclusion was that, sir, using vernier caliper, which has the least count, a general vernier caliper has a least count of 0.01 centimeter. A general vernier caliper has a least count of 0.01 centimeter. So basically, you can take the measurements up to the accuracy of second decimal place, right? Okay, okay. So vernier caliper is an improvement over the meter scale. Now, this we have today. What we are going to discuss about. So, sir, today's session we will be discussing. In today's session, we shall be discussing about the screw gauge. Okay, it is also known as micrometer screw gauge. Both are the same thing only. Okay, it is also known as micrometer screw gauge. Okay, so why it is called also as the micrometer screw gauge? So, so many says that it can measure till micro level, so that is why it is not the reason. The reason is it basically works on the principle of micro screw. Okay, okay, okay. So that is why it is called as micrometer screw gauge. This hardly concern you. Okay, okay. Now we understand that in order to improve the precision of taking the measurement, in order to improve the accuracy, the least count shall be as less as possible. Right? We know this now. Yes, sir, absolutely, we know this fact. So, since the now see, least count 0.1, so a general meter scale has a least count of 0.1 centimeter. A general vernier caliper has a least count of 0.01 centimeter. Okay, sorry. Okay, a general vernier caliper has a least count of 0.01 centimeter. Now, similarly, a screw gauge, a general screw gauge. I'll help you calculating the least count. We are going to see it in very good depth. Okay, there is nothing to worry about it. So we are going to see in very much depth that how is the least count of it is calculated. Okay, okay, and everything, right? Okay, we are going to see that. Okay, but for time being, I am writing here that the least count is 0.001 centimeter. So this is the least count of a general screw gauge. What do we mean by the general screw gauge? So as I said in the session of vernier caliper, so in the market this screw gauge is available. You might have done this in your laboratories also. So the general screw gauge, the general screw gauge that we are having is having a least count of 0.001 centimeter. Okay, okay. So basically in these three, okay, which one is the most accurate? So sir, screw gauge is the most accurate because it has the least count. So the instrument which is having the least count is the most accurate one, right? Obviously, sir. Obviously, okay. So what is the use of a screw gauge? General screw gauge, although it can be having least count, anything other than this also will be measuring that, will be taking care of it. Okay, that is a different thing. Okay, but in general, okay, the screw gauge available in the market has this much least count. Okay, so what is so exclusive about it? So see, if you want to take measurement of some length from the meter scale, you can measure accurately up to one decimal place. Okay, you can measure accurately up to one decimal place. Then we can do it up to two decimal place. Okay, two decimal place, and this is up to three decimal place. Okay, because it is having a least count of 0.001 centimeter. So if we are measuring anything in the unit of centimeter, we can have the accuracy till the third decimal place, right? Okay, very simple. Now see, we are going to analyze the screw gauge now. So the analysis is very much similar to what we have done in the case of this, you see, in the case of, you see, this 1 year caliber. Okay, okay. In the case of this 1 year caliper, so it is very similar to the case of this 1 year caliper. So let us move. Let us see what is how this screw gauge is looking alike. Okay, so I'll just give you one photograph of it. Now please observe. Now please observe. Okay, let me take it here. Yeah. Now this is a simple screw gauge. Okay, this is the geometry of a simple screw gauge. Right. Now please observe this thing. Just take a look at it. Just take a look at it. I'll just explain to you. Just first have a look at it. So like when we see something very beautiful, no, we hold for a moment and appreciate the beauty of that thing. In the same way, you have to take a look. You have to see this. Okay. Okay. Now let me come to the point. Okay. Now please understand this. So see, I'll be here talking about. So I'll just tell you the briefly. So basically, this is an anvil. Okay, this is an anvil. It is also known as the stud. Okay, sometimes you must not tap into the language. So it is the stud. This is a spindle. Sometimes it is also known as the screw. Okay, also known as it is also known as the screw. Okay, okay. So basically, what happens? First of all, so in the 1 year caliper, we have seen few jaws now, right? In between those jaws, the measurement, something whose measurement is to be taken was hand, right? Now, similarly, in the case of this screw gauge, in the case of this screw gauge, we are holding whatever object measurement we have to do in between the stud and the screw, in between the stud and the screw. Okay, in between the stud and the screw. Okay, so when we hold something in between the stud and the screw, when we hold something in between stud and the screw, we can then make the measurement. Okay, so in the 1 year caliper, we used to take the reading using the main scale and the 1 year scale. Same way here. If you see the scale, so see here we have the sleeve. Sleeve is also known as the main scale. You can sometimes call it as the main scale. Okay, and you can sometimes also call it as the pitch scale and the pitch scale. And this is the thimble. So there is one circular scale over it. This is a thimble. That is, we are having a circular scale over it. So this is known as the circular scale. Okay, hand scale it is also sometimes we call. Okay, circular scale, thimble. Okay, thimble like this. So you can see that this divisions are there. So these are on this thimble, that is the circular scale. These are some divisions on the main scale. So thimble is also known as this circular scale. Okay, this circular scale or head scale, it is also known as, okay, head scale. Right, I'll write it here. Head scale. Okay. So all these names are different names. So sometimes in the exam they may confuse you with this names also at times, right? So we don't have to be confused in that. Okay. Okay. So we have we are placing some object between anvil or a spindle. We are holding some object between anvil and a spindle. Now, when we hold something between anvil and a spindle, there will be some reading on the main scale, there will be some reading on the circular scale. Using them will give the final. I'll come to that. Let's first sort out the name. Okay, then this is the clamp, this thermal protection cover, you don't have to do anything. Okay, this is the frame, just to give some rigidity to this instrument. It's very small instrument, right? Normally used to measure very small diameters. Okay, very small measurement. Like if you want to measure the diameter of a wire, very small thing, no? Wire. So if you want to make such precise measurements, at times you are using this screw gauge. Okay. For normal length measurements, we never use this screw gauge vernier caliper. Okay, because see, please understand this. Why? Sir, we can make every measurement from the screw gauge, from the vernier caliper. What is the problem? The problem is the ease of use, right? The ease of use. Now, at every place, like whatever we are reading, it has at some point of time some application, right? Okay. Now, when you think about the application to it, okay, is it possible every time that you open a screw gauge, then you do so many things? To take a measurement, it is at least going to take 4 to 5 minutes. Okay. Okay. Practically. Okay. When you become expert, it may take 2 to 3 minutes. But from the meter scale, you can do it like less than in a minute, like 30-20 seconds will be more than enough. So for the ease of use also, instruments are decided or selected for any application on the basis of many things, right? So please think in that way also. So there's a frame, thermal clamp is there, okay? Key spanner, all these things are nothing to be used upon. Okay, for as far as we concerned. So there is one thing ratchet in that. Now please let's understand it. Let's suppose I have this pen. I want to measure the diameter of this pen from this screw gauge. So what I'm going to do, I'm going to place this pen in between the anvil and the spindle. You can say stud or the screw. You can say jaws also. Okay. See, whenever you have to make the contacts. Okay. Now, when you are holding it, okay. So in the first case, let's say we have. So today I just didn't get the screw gauge from the lab. Okay, was busy in something. Otherwise, I would have shown you. Now, please understand this first of all. Like, so I'll just show you one more picture. Okay, so you see that's whenever we are measuring, whenever we are taking up a screw gauge. Okay, we are having a very nice box of it. Now from the box, when I I opened the box, I took out the screw gauge. So initially the screw gauge will look like somewhat like this in this condition. Okay, both the anvils are meeting each other. They are closed. Okay, they are closed. So this is the condition of the screw gauge before measurement. Okay, this is the condition of screw gauge before measurement. So before measurement, you are holding these when you are keeping this like in a closed situation, sir. But when we use things at times and we never close it, like sir, we have the water bottle, we open it, we keep it like this. Okay, so normally when you are doing with sincerity, you don't do like that. Are you getting my point? So when you are placing an instrument, you have to place it with respect. Okay, and when you are placing it with respect, so that means you are closing it. Now it is in the closed condition. Now please listen to me. Okay. Now you want to measure the diameter of this pen. So what you want to do? You want to open. Okay. When you want to open between, you want to open between this you want to open between this anvil and a spindle. You want some space between them. Na? So why would we want some space between them? Otherwise, where we will fit this object? Okay. Now to open it. Now before we open it, just make an observation that when you are seeing it like this, okay, wow, the pen is in my hand. I was searching for where is the pen. Okay, so when we were having this situation, now please see this main scale. Okay, this is the main scale here, na? Okay, this is the main scale. See, this is the main scale. Now, please observe. So, in this condition, the main scale is completely covered by the circular scale. So, one information that I want you to process, that under the closed condition, when it is closed condition, that is not in use condition or before measurement condition. Okay, so in the condition before measurement, this is completely closed. Okay, the main scale is completely covered by the circular scale or thimble. You cannot see any division. You cannot see any division on the main scale. Now, what is going to happen? You want to open it. Why you want to open it? Because you want to hold the object. So for that, you are going to give a anti-clockwise turn. You are going to turn this in the, you are going to turn this thimble. This is looking like somewhat like this. So you are going to turn it in anti-clockwise direction. And when you turn it in anti-clockwise direction, guys, what is going to happen? It will, you will start seeing that the some space is making between. So more rotation you do, more space. More rotation you do, more space will be there between a stud and the spindle. That is between the jaws. Are you getting my point? So initially you have to open it to hold the object. Okay. Now in this situation, you can see that we have some opening in between, and now you can see some part of the main scale is visible, some part of the main scale is visible, and there is some space. Now if you want to open more of it, you are going to rotate it further in anti-clockwise direction. Okay, okay, okay. So you keep rotating it anti-clockwise direction, more main scale will be visible. Basically, what is happening? This thimble, this circular scale is now getting unfold over the sleeve or the main scale, exposing more and more divisions on the main scale. Okay. When you are rotating in clockwise direction, more and more divisions are getting exposed on the main scale. Right? Right? Now you have placed this. Okay. Okay. You thought, okay, this much opening is perfect, and you have placed it. Now, when you have placed it, now how would you know that your placing is perfect? Now, obviously, if you have moved the thimble or the circular scale more than required, okay, that you may have given more anti-clockwise movement to it, what you can do, you can turn it in clockwise direction. The space between them will be reduced. Very simple way. See, when you see like the tap only now, taps we are using at homes. Okay, when you rotate the tap in one direction, the flow of the water increases. Okay, and when you want to close the tap, you want to stop the flow of the water, reduce the flow of the water, you rotate that tap in the opposite direction. Now in the same way, when you rotate the thimble, okay, in anti-clockwise direction, more opening will be there in the main scale. If main scale divisions will be more and more exposed, the distance between the spindle and anvil will increase. When you rotate it in clockwise direction, it will decrease. Okay. Now, when you feel that this is held perfectly, then you have to rotate the ratchet. This is the purpose of this ratchet. Okay. When you rotate this ratchet, you are thinking that it is perfectly closed. So if it is perfectly closed, I'll tell you a little practical thing. So then when you rotate the ratchet, you will get a sound like cut, some cut type. Okay, some sound, okay, will come there, and if that sound came, that means that this is perfectly held, and now you can take the measurement. So this is how you take the measurement. Okay, so why you are explaining like this? Sir, now this topic is in the unit of 20, which is experimental understanding. Okay, so I'm trying to give you some experimental understanding as well. Formula can be told by anyone, no? Okay, now please understand this. Now please understand this. So we have now this. We now have this thing with us. We have now this thing with us. So we have opened it to some extent. Now, sir, how we take the reading? But before that, sir, we need to understand. We need to understand the least count of it. We need to understand the least count of it. So before we understand the least count, I want you to understand the pitch. Okay. So, sir, some screw sort of thing is there. Na? This is some sort of a screw. If you see this image, this is some sort of a screw. Na? Okay. Thread. I may say thread. So basically, this sleeve have some sort of a, not sleeve, this spindle have some sort of a thread. Okay. Now please understand. So there is something that you must understand before we go for the finding the least count, and that thing is the pitch. Okay, that thing is the pitch. Now, in context to the threads, okay, threads in context to the threads. So we all must have seen the threads in our life, no? We all must have seen the threads in our life. Okay. Now, when I talk about this threads, guys, so screw, you must have seen this screw, nut screw. Okay, so many things you must have seen in your practical daily basis life, right? Now, when I talk about this pitch, guys, okay, basically when we have some thread on something, please observe. Let's suppose we are having some threads there. Okay, this is some sort of a threaded cylinder or threaded body screw or something like that. Something like that. So what is this pitch, guys? What is this pitch? Please understand this. What is this pitch? So basically, pitch is the distance between two consecutive threads. Okay. Okay. So there are so many threads now. Threads. Okay. So pitch is the distance between the two threads. Okay. In respect, in any thread you talk about. Okay. Okay. Like nut, screw, thread. There are so many types of thread also. We are not going into depth of that. Okay. Okay. But simply the distance between two consecutive threads. Okay. Okay. Like the distance between these of two. You can take the distance from beginning to beginning, from initial points of both these threads or final points of both these threads or center to center, whichever suits you. Okay. But simply the distance between the two threads is the pitch. Okay. So first thing about the distance between two threads. Okay. Two consecutive thread, I must write. Two consecutive thread is the pitch. This is the first understanding of the pitch that we got from here. Now the second thing, please understand this. Please understand this very, very carefully. Now please think. So now, guys, we have this like this. We have like this. Now please understand. So what I told you, when we give, now please listen to this thing very, very carefully. This is like the heart of this discussion. So when you rotate this thimble by one rotation in the anti-clockwise direction, there will be some movement of the spindle. What is this spindle? So this is the spindle, right? On which threads are there? Okay. So basically, when you rotate, please observe, when you rotate this thimble in the anti-clockwise direction, there will be some movement of the spindle. Okay. Okay. Now please understand this. So this screw gauge is designed in a way that when you rotate this thimble by one rotation, this spindle moves by the distance equal to one pitch. Please understand this. I am repeating myself. When you give this thimble one rotation, the spindle will move by the distance equal to one pitch. Okay. So if you are giving anti-clockwise rotation, so think you have rotated this screw gauge by one complete rotation in the anti-clockwise sense. So what happens? This spindle move backwards. Okay, backward I'm saying in the direction where opening is increasing. So when you give it an anti-clockwise turn, the spindle is moving backwards by the distance equal to one pitch. The distance equal to one pitch. Okay. Okay. So may I write it here? Okay. So the second important point about the pitch, so it is the distance. It is the distance by which the spindle move in one complete rotation of the thimble, or you can say the circular scale, whatever. Okay, both are the same thing. Okay, so it is the distance by which the spindle move in one complete rotation of the thimble. I hope it is fine to everyone. Now, please understand this. So, pitch is the distance between two threads. This whole device is designed in a way that when you rotate this thimble by one complete rotation, the spindle moves a distance which is equal to the pitch. Now, the third and the most important thing here is that this pitch is also equal to pitch is equal to the division on the main scale. Now, please understand this, guys. So we are seeing that there are some. So see, this is the main scale. I'll make main scale here. Okay, please understand this. This is your main scale. Okay, and somewhere over it there is the thimble. Okay, or the circular scale, like this. Okay, like this. Now, please understand this. So we have, this is the baseline. Okay, on the main scale we have this baseline. Okay, this baseline. Okay, and there are some, so I'll talk about the readings on the circular scale later. Let's first understand the readings on the main scale. So we have some readings here: 0, then we have 1, 2, 3, 4, 5, then we have 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4. This is 2. Okay, this is 2. So this is the baseline. So see, please understand this. On this main scale, we are having some divisions. Okay. Now this device is designed in a way that each of the division, that is the marking, that is the distance between these two. Okay. These two is equal to the pitch. Okay, the pitch of the thread. Okay, so this pitch is very, very important in context to this screw gauge. Now, please understand this. I hope you have understood it. Let me explain it like it in a different way. Okay, so like this is the closed situation. Please understand this. In this closed situation, please observe. See, this is the closed position. Just so I'll make it here. Now, this is the position when you have taken out the screw gauge from your beautiful box. Okay. So from the box, when you take out this screw gauge, it looks like this. There is no division on this main scale is visible. Now you have given it one complete rotation. Let's suppose afterwards you have given it one rotation. So after one rotation, how it is going to be looking like? Please observe this. So after one rotation, see, this will be, let's suppose, the baseline on the main scale, and this is 0. Now you will see that after one complete rotation, your thimble or your circular scale will be somewhere here. Okay, will be somewhere here. And you can see now one complete division you can see. Okay, okay. And if you now please understand this. So initially, now see in this closed situation, let's see this. So in this closed situation, you can observe the zero here. Na? So even in closed condition, you can observe the divisions on the circular scale. Please understand this. So this is zero here. Now this is zero here. This is zero here. So now the zero coincides. So whenever you make one complete rotation, the zero on the circular scale will coincide with the baseline. Will coincide with the baseline. So zero is here, guys. Zero is here. So when zero is here, guys, zero is here, zero is here. So one complete rotation. So now you can see after one rotation, one division on the main scale is visible to you. That means your spindle is moved by a distance of one pitch. Okay, so one division. So one pitch distance is visible to you. Now let's suppose that it has now taken second turn. You have given it two complete rotation from its initial position. So when you give it complete rotation from the initial position, this is your baseline. So afterward, what is going to happen? 0, 1, and 2. Now you are going to see one more. Now you are going to see one more division here, because you have given two complete rotation. So when you have given two complete rotation, now you can see two divisions here. Now you can clearly see two divisions here. Okay. If you give one more rotation to it, what is going to happen? If you give one more rotation, so if you give three complete rotation to it, please understand this. If you give three complete rotation to it, see 0, 1, 2, 3. Now your thimble, after three complete rotation, your thimble or circular scale will be somewhere here at this position, and its 0 is going to coincide with the baseline like this. So whenever you are giving the complete rotation, at the end of complete rotation, you will see that the 0 of circular scale coincide with the baseline of the main scale. Okay. Now if I say, let's suppose our object measures 6 mm. Okay. Let's suppose that pitch is 1 mm for time being. Let's suppose the pitch is 1 mm. Okay. Now if pitch is 1 mm and you have given 6 complete rotations to the thimble in order to hold some object. Now if I ask you what will be the length of that object, what would be your answer? Please answer me. What would be the length of that object? What would be the length of that object? Can you answer me? So, sir, obviously, when you have given 6 rotations, 6 complete rotations to the circular scale, that means on the main scale, 6 divisions are exposed. So, when 6 divisions are exposed, that means that the main scale reaches 6 mm. Okay, so when you have given exact 6 mm rotation, to the circular scale, it means that you are holding an object which is having the dimension of 6 mm. Okay, 6 mm. Very easy, sir. Very easy. Now, let's talk about it. So now I want to ask you, what is the least count? What is the least count of a screw gauge? What is the least count of a screw gauge? Now, please observe, if you use little of your common sense, you will be able to get it. Now, please understand. So, what is the minimum measurement we can take from the screw gauge? Sir, when we rotate the circular scale, it is moved by a distance equal to 1 pitch. Okay, so we can make the minimum measurement of 1 pitch, right? Is it so? No. You are getting it wrong. Please understand. Is it necessary always that we rotate the circular scale by one complete rotation? We can rotate it half of the complete rotation. We can rotate it 1/4 of the complete rotation. We can rotate it 1/6, 1/8, 1/10, 1/12, 1/15, 1/20th of the full rotation. Yes or no, please answer me. See, when you rotate the circular scale, in one complete rotation, it covers a distance of one pitch. Okay, okay. So when we rotated it to 6 complete rotation, we can measure 6 mm. Okay, but if the length of the object is more than 6, but less than 7, so you have rotated the circular scale somewhere between 6 complete rotations to 7 complete rotations. So you may have rotated it by 6 complete rotation and 1/4 of the next complete rotation, right? Okay, so please understand this. What is the least count of the screw gauge? So 1 mm, if we want to measure 1 mm, one rotation, okay, 1 mm, one rotation, okay. So zero point 0.5 mm is half rotation, okay. General I'm talking. Okay, so is the 0.5 mm the least count? Sir, we can rotate by 1/4 also. So 0.25 mm we can get 1/4 rotation. So is it the least possible measurement that we can do from the screw gauge? No, sir. Least possible. What is the least count? Least count is the least possible measurement that one can do from an instrument. So from the screw gauge, the least possible motion, the least possible measurement would be the least amount by which you can rotate the circular scale, isn't it? Okay, please answer. Okay, okay, please answer. Please think, please think. So see, if we can, what is the minimum amount by which we can rotate this circular scale? Please listen to me again. See, you are understanding that it is not always necessary to make the complete one rotation of the circular scale. In one complete rotation, it measures 1 mm. In half rotated rotation, it measures 0.5 mm. In 1/4 rotation, it may measure 0.25 mm. Okay, so what is the minimum rotation? What is the minimum rotation? So the least count is basically the minimum rotation, the minimum rotation of circular scale, minimum rotation of the circular scale. Now how I am going to get the minimum rotation of the circular scale? Now see, please, let's go back to this image. Now in this you can say there are divisions on this circular scale, and how many divisions we do, how many equal divisions we do on this circular scale is up to us. Okay, now there are divisions on this circular scale. Now please observe, please understand this. So if there are 100 divisions, if there are 100 divisions on circular scale, on the circular scale, so that means, guys, that the one rotation, that means that one rotation is divided into 100 parts. If circular scale is having 100 divisions, one rotation, one small rotation you do, it rotates by one division. Another is small, two divisions. Another is small, three divisions. Like that, like that, like that, like that. You will rotate it by 100 divisions. That means one complete rotation is computed. So it means that you have divided one rotation into 100 parts. Okay, into 100 divisions. You have divided one complete rotation into 100 divisions. Okay, so if there are 100 divisions on the circular scale, that means the least count, okay, is, so what is the least count? In one complete rotation, it moves by a distance of a pitch. So 1 by 100, okay, 1 by 100. So if pitch is 1 mm, and divisions on the circular scale is 100, so that means that it can be rotated by 1 by 100 of a revolution, and in that it will move by the distance 1 upon 100. So this will be 0.01 mm or 0.001 centimeter. So in the general screw gauge that is available with us, it has 100 division. That is why we say that the least count of the screw gauge, which is generally available in the market, which is generally available, we generally see in the laboratories, industrial purposes, or anything, it has a least count of 0.001. Okay, okay. I hope it is fine to everyone. So the least count is 1 by 100 of mm in general case. General. Remember, don't forget it. General. Now, if I make the formula of the least count of a screw gauge, very important, least count of a screw gauge, it is going to be equal to pitch upon number of divisions, number of divisions, okay, on circular scale, number of divisions on the circular scale. So this is the formula of least count of screw gauge, pitch upon number of divisions on the circular scale. I hope it is fine to everyone, and I hope you have got the feel of it. See, sometimes understanding the concept is very, very important. See, I could have given you this formula beforehand also, right? Okay, so this is the formula of screw gauge. Okay, go solve the question. And almost 70-75% question you could have solved also. Okay, but the problem is, unless you understand the concept of something, firstly, there will be problem of retaining it into your mind. Secondly, you will not be able to understand the language of the question if twisted at all. Okay, so if the language of the question is twisted, you will not be able to understand. Okay, so now to save you from all these possibilities, I am giving you all that. Now please understand this. Let's solve some question. Okay, so I'll give you some questions. Now, let's try it. See, let's have some question. I'll have to write it. Nobody. So we have a question: two full turns of the circular scale, two full turns of the circular scale of a screw gauge, okay, of a screw gauge covers a distance of 1 mm on scale, covers a distance of 1 mm on scale. The total number of divisions, the total number of divisions on circular scale is 50. Okay, find the least count. Find the least count. So basically what happens, to full turn of the circular scale of the screw gauge covers a distance of 1 mm on scale. The total number of division on the circular scale is 50. Find the least count. So what is the least count, sir? Least count is pitch upon number of division on the circular scale. So number of division on circular scale. NDCS. Number of division on circular scale. So what is the pitch? Now please understand. Two full turn of the circular scale. See, this is how they manage the language of the question and get students confused. So two full turn of the circular scale of screw gauge covers a distance of 1 mm. So two rotation, the distance covered is 1 mm. Okay. Now we know what is the pitch. Pitch is the distance covered by the spindle in one rotation. So if on two rotation we are having the distance covered as 1 mm, so in one rotation it will be 1 by 2 mm, and this is nothing but the pitch. This is nothing but the pitch. So pitch is how much? Pitch is 0.5 mm. Pitch is 0.5 mm, and the divisions on the circular scale is 50. So what it is going to be? It is going to be how much? It is going to be 0.01 mm. So what is the least count here? The least count is 0.01 mm. I hope it is fine to everyone. So all the students who are watching live, they can solve right now. And the students who are watching the recorded mode, you may please pause the video and solve it before I do. Okay. Okay. Now one more question. The least count is given to be the least count of the main scale. The least count of the main scale is given to be 1 mm. Okay. The minimum number of divisions, okay, divisions on circular scale, to measure 5 micrometer dia of wire. Okay, so the least count of the main scale is given to be 1 mm. Now the minimum number of divisions on circular scale to measure 5 micrometer dia of wire. So what is it? How we can calculate that? Okay, how we can calculate that? So it's very easy. I hope you have solved this. So least count we know is pitch upon number of divisions on circular scale, NDCS. So they are asking you this NDCS thing this time. So the least count is to the least count on the main scale. Now least count on the main scale. So what does that mean? So right away this is pitch now. Pitch is 1 mm. Sir, how come they are writing least count? So how come this is the pitch? How come this is the pitch? Sir, the main scale, what is the least count? So least count is the minimum measurement which can be done from any particular instrument. So when they say that the least count of the main scale, that means the least count of the main scale means that what is the minimum measurement the main scale can do. And the main scale can do the minimum measurement equal to its pitch, because that is the distance between two markings. That is the distance of one division. Okay, so pitch is clearly 1 mm. Now they are asking you minimum number of divisions to measure 5 micrometer wire dia. So basically minimum number of division, that means you don't want to measure anything less than this. Okay, so basically this is the least count of screw gauge. Okay, least count of the screw gauge. So from a device, what is the minimum measurement that you want to do? From a device, what is the minimum measurement you want to do? It is what we know as the least count, right? It is what we know as the least count. So this 5 micrometer is the least count. So this will become 5 into 10 to the power minus 6. Okay, so we know, and pitch is 1. So from here we have NDCS. Okay, 1 mm. So we can write 1 mm we have put there. So we can place this in meters. So 5 into 10 to the power minus 6 meter. No. Okay, or we could have written 10 to the power minus 3 by converting this micrometer into mm. Okay, whatever way you refer. So from here, this number of divisions on the circular scale will come out to be 200. I hope it is clear to everyone. Okay, I hope it is clear to everyone. Right? Okay. Now let's. So I hope from here you understood that how do we calculate the least count of any measurement. Now we'll come to finding reading. Okay, so what we can do to find the reading? So it is very similar. It is very similar to that of the vernier caliper. Okay, so obviously, so now this is going to be very easy. It is going to look like very easy to you. Why so, sir? Because we just have completed this vernier caliper. No, we just have completed the vernier caliper. Okay, so when we just have completed the vernier caliper, so from that context we can very easily do this thing. So how we find reading? So the total reading, so like the vernier caliper, so the total reading or the reading only, okay, the total reading is equal to, again, MSR plus CSR. Okay, in the case of vernier caliper, we use MSR plus VSR. So here, what is the MSR? MSR is main scale reading. Okay, it is main scale reading, And what is CSR? CSR is circular scale reading. Very, very simple. Very, very simple. Circular scale reading. Okay. So, like the vernier caliper, the screw gauge reading, complete reading that you take out from the screw gauge is the main scale reading and the circular scale reading. So, to get the reading out of the screw gauge, you have to see both these readings. Okay. Okay. So, what is this main scale reading? What is this MSR? How you will see this MSR? So, MSR is the reading. It is what? It is the on reading on main scale just before zero, like the same way, just before zero of circular scale, just before zero of circular scale. Okay, didn't get that. So let's suppose we are having, so we held an object or something in between, the jaws or the spindle and the stud. So you have rotated it to some point, and after that you have ratchet, you have used the ratchet, you held it completely. Now you want to take the reading. So this is your baseline. This is what? This is my baseline, right? Okay, baseline on the main scale. Now please observe, very, very simple. So there are some, divisions here. So it will be, let's suppose this is 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, like this. Okay, like this. And afterwards we have some more reading. Okay, like this. Okay, like this. Now please understand this, that let's suppose your circular scale is somewhere here. Your circular scale is somewhere here. Okay. Okay. Now you understand this. Now you understand this. See, firstly we'll talk about the main scale. So see, now this circular scale is not at any one of the division. If it is exactly on any one of the division, that means that your thimble has rotated by the complete rotations only. And if it would have, like we have seen here, na, see, in this cases, when this line is coinciding with the divisions, there will be zero. There will be zero here. Now, please understand this. Please understand this. So now, in this case, that it will not be zero. It will not be zero when it is somewhere here. So this yellow line you wouldn't have been seeing also. I have made it here. Okay, I have made it here like this. So this is also not. So I'll just do like this. Okay. So let's suppose that this is here, na? Because see, when the circular scale will be there, you cannot see reading because this circular scale will be complete, will be, covering this reading. Okay. Okay. Now this thimble is not exactly on any of the divisions. So there will be no zero here. Na? There will be some number. It could be 8, 10, anything. Zero will not be here. So let's suppose this is 8. Okay, this is 8. Okay, okay, 8 division is cutting this. So how you are going to have the main scale reading? So what is the main scale reading? So you will see what is the main scale reading. It is the reading on main scale just before 0 of CS. Okay, okay, so this is the 0. This is the 0. So wherever it is like this. Okay, now please observe this, how we are going to calculate it. Very, very simple, no? Okay, okay, okay. So this is 1, this is 2. So basically main scale reading is 2.2, right? If the least count or the pitch is 1 mm. Okay, so this is 2.2 mm. Do you agree or not? This is 2.2 mm, right? Please answer me. Okay, the main scale reading is going to be somewhere 2.2 mm. Okay, okay. Now, so same way you can read, you can get the main scale reading, isn't it? Okay. Okay. Please answer. The reading on the main scale is the reading just before 0 on the circular scale. So this is how you can see it. So main scale reading is done. Main scale reading is done. Now what is this circular scale reading? So what is this circular scale reading? So please understand this. So this circular scale reading. What is the circular scale reading? Please understand this. So we have learned this concept. Now if this is 8, so what it means? That this has taken, the thimble, the circular scale has taken two complete rotations. One rotation, it will move by 1 mm. Okay. Okay. So it is actually, sorry, my bad. Now, this is 2.2 centimeter now, because I have said that 1 mm. So this is 1 centimeter, this is 2 centimeter. Okay. This is 2 centimeter, this is 2.2 centimeter. This is 2.2 centimeter, not mm. Because 2.2 mm would be somewhere here now. 2.2 mm is this. If this thimble would have been here, that will be 2.2 centimeter main scale, mm main scale reading. I hope just the glitch of the unit. Okay, so this is 2.2 centimeter. Okay, so what does that mean? So see, please try to understand. One rotation, 1 mm. It has taken 2.2 centimeter. That is, it has moved by 22 mm. So we have made 22 complete rotation of the circular scale till now. And now, since it is coinciding, so there are divisions here now on the circular scale. There are divisions on the circular scale. Now, 8, this 8, this 8 is coinciding with the baseline. Now, what does it mean? That means from 0, this circular scale is rotated by 8 divisions. Okay, so you have taken 22 complete rotation, and then you have rotated it further by 8 divisions. Are you getting my point? This is 8 here. That means after complete rotation, you have further rotated it to 8 divisions. Okay, okay, okay. So whatever are the number of divisions on the circular scale, you have rotated it by 8 divisions. So what is this circular scale reading? So circular scale reading, I'll just give you. So circular scale reading is basically what? It is the least count. See, very similar to that what we have learned in the 1 year scale. So 1 year scale reading was what? Least count into the coinciding division of 1 year scale to the main scale. Now in the same way, CSR, that is circular scale reading, it is going to be the least count into coinciding division, least count into coinciding division of circular scale with baseline. Okay, so at the end of measurement, you will see there will be some division that would be coinciding with the circular scale. Okay, baseline of the main scale. Okay, okay. So all you have to do, you have to calculate the least count. Least count we already have calculated, and then you have to multiply the least count with coinciding division of the circular scale with the baseline, and you get the CSR, that is circular scale reading. So in this case, what is the CSR? So eighth one is coinciding. Eighth division is coinciding. So if the least count is 0.001 centimeter, okay, then eighth division is coinciding. So CSR is 0.001 into 8. So what will be the total reading? It will be 2.2 plus 0.001 into 8 centimeters. I hope it is fine to everyone, right? Okay, I have written it here. So what is the total reading? Total reading will be the summation of the main scale reading and the circular scale reading. I hope it is fine to everyone. Okay. Okay, so we have understood this. Now let's solve a few questions, and afterwards we'll understand it in a further better way. Okay, let's solve this question. So we are trying to calculate the diameter. We are trying to calculate the diameter of a wire, and it is given that the circular scale has 100 divisions. So now you need to calculate the diameter of the wire. Please go for it. Please go for it. The live students can answer it here. The recording students, those who are watching this after not in the live session, they can pause this video and can solve it. Please go for it. Please go for it. So very simple, sir. Very simple. Sir, clearly the pitch is 1 mm. Sir, how come? Sir, here it is written the main scale is in mm. So each of the division is in mm. So one division of the main scale is nothing but the pitch. Okay. Then what is going to be the least count? So least count, we know that it is pitch upon number of divisions on circular scale. So pitch is 1 mm, number of division on the circular scale is 100, that is 0.01 mm. That is 0.01 mm. So we have the least count here. We have the least count here. Now what is the main scale reading? So main scale reading is clearly 5, sir. Clearly 5. What is main scale reading? Main scale reading is the reading on the main scale just before 0 on the circular scale. Okay, so the main scale reading is 5. The main scale reading is obviously 5. Okay, okay. Now, what is the circular scale reading? It is the least count into the coinciding division. Now, let's see the coinciding division. So, this is 30, this is 40. So, now see 30. So, this is 31, 32, 33, and 34. This is 34. So the 34th division is coinciding. So 34th division is coinciding. That means it is 0.001 into 34. So what is going to be the total reading? Total reading is going to be 5 plus 0.34 mm. So that means it is 5.34 mm. That means 0.534 centimeter. 0.534 centimeter. I hope it is fine to everyone, right? Please answer. Right? Okay, let's do one more question. Okay, so okay, I'll have to write it. See, the thimble of a screw gauge has 50 divisions. It has how much divisions? It has 50 divisions. Okay, and a spindle advances 1 mm. A spindle is advances 1 mm when the screw is turned through 2 rotations. Okay, 2 rotations, right? When so the reading on the sleeve is 0.5 mm, and on thimble is 27 divisions. On thimble it is 27 divisions. Okay, what is the dia of wire? So they are trying to measure the diameter of wire. So the options are 0.027 centimeter. Option B is 0.005 centimeter. Option C is 0.077 centimeter. And option D is 0.035 centimeter. So all these options, whatever are there, now you have to get me the final answer. What is the total reading? What is the final diameter of this wire? So now, sir, very simply we can do. The thimble of a screw gauge has 50 divisions and its spindle advances 1 mm. So pitch is 1 mm clearly. Okay, pitch is 1 mm. Now the pitch is 1 mm. So the least count is pitch upon number of divisions. So it is going to be, oh sorry, pitch is 0.5 mm, no, not 1 mm. Pitch is 0.5 mm. Sir, how come it is 0.5 mm? Sir, the screw is turned through two rotations. We have to read question carefully now. So when a screw is turned through two rotations, it advances by 1 mm. So the pitch is 0.5 mm, first of all. Now pitch is found. So what is the least count? Least count is pitch upon number of divisions. So 0.5 upon 50. So it is going to be 0.01 mm. So the least count is 0.01 mm. Very nice. Now, what is the total reading, sir? It is the reading on the sleeve. So, what is the reading on the sleeve? Reading on the sleeve is 0.5 mm. Reading of the sleeve is 0.5 mm. Okay. And what is the reading on the thimble? So, reading on the thimble means circular scale reading. So, what is the reading on the thimble? We have reading is 27 divisions. Least count is 0.01 into 27. So from here we'll get whatever is the answer. I hope it is clear to everyone. So what we are getting? We are getting 0.27 and this is 0.5. So 0.77 mm. That means 0.77 mm we are getting. So it will become 0.077 centimeter. Right? 0.077 centimeter. Right? Very, very simple. So like how we can get the reading of the screw gauge using the main scale reading and circular scale reading. I hope that is also very clear to everyone. Now one last thing in the screw gauge and we will complete the units and measurement. So I'll come up with one complete marathon session in which I'll completely do the units and measurement in one session shortly on like a quick revision. Okay, so with this session we shall be completing this particular chapter. I'll be giving you some PYQs also. So PYQ sessions will be there, but the concept, the content of the chapter will be completed with this. Now please understand this. So we have one more concept, that is zero error and correct reading. So this thing we have learned in the 1 year caliper too. It is exactly the same. See, after you study the 1 year caliper and then you study the screw gauge, it will be very, very simple. Okay, it will be very, very simple, and vice versa too. If you study screw gauge first, then 1 year caliper, both are very much related to each other. So what is this zero error? What is the zero error? So what is the zero error in 1 year caliper? So in the closed condition, the zero of the screw gauge must be in the line with the baseline. Okay, like this. I'll just show you. See. Okay. Please observe this first condition. This is the baseline. So whenever you are talking about the zero error, like in the case of the 1 year caliper, you always see this before measurement. So it is having no zero error. See, very, very simple, like the one we have seen in the 1 year caliper. So if zero coincides with zero, okay, that means in the closed condition, zero is coinciding with zero, that is, there is no zero error. Your screw gauge is perfectly working well. Okay. Now in the second and the third condition, you can see that in this condition, zero is below. Zero of the circular scale is below the baseline. Okay. This is what we call as the positive zero error. This is what we call the positive zero error. Okay. So what is the positive zero error? So positive zero error. So the zero of circular scale, if below the zero of the baseline or zero of the main scale or the baseline, that is positive zero error. And in this case, this is negative zero error. This is what? This is your negative zero error. I'll write here negative zero error. Okay. Very, very simple. Okay. Very, very simple. Okay. If zero is below, then it is positive zero. If zero is above, it is negative zero. Okay. Why we call it positive zero? Because you think yourself, if in the initial condition there zero is below this baseline, when you are going to measure it, you are going to get the measurement which is higher than the actual. Okay, isn't it? Because zero is below, na? So when you start rotating, it will first come to 0. Then we'll take the measurement actual. When it comes to 0 first, that means this distance will be added in the final reading. Okay. Similarly, negative 0. So the 0 is above. So from here you are measuring. So when you are measuring from this point, that means this distance, this initial distance, you haven't considered in your measurement. Okay. Okay. So again, very simple. See, the formula is what is the correct reading? Correct reading is, so what is the reading of the screw gauge? What reading you have taken? Okay. Minus 0 error. Always you have to do minus 0 error. Okay. Like in the same line with the vernier caliper. Okay. Now what is the positive 0 error? What is positive 0 error? So positive 0 error is plus, okay, least count, okay, plus least count into coinciding division of circular scale with baseline. Okay, coinciding division of circular scale with the baseline. Okay, so you already have the least count. So if you have positive 0 error, you can calculate the positive 0 error and it will come into the positive. Okay, so least count into coinciding division of circular scale with baseline. And obviously you have to measure it before measurement. Okay, always 0 error is to be measured before measurement. And similarly, the negative 0 error will be, minus of the least count into coinciding division of circular scale with baseline. Okay, so formula remain the same. What you can do, you can find the 0 errors in both the cases. If the 0 error is positive, it will come in positive sign. If the 0 error is negative, it will come in the negative sign. So let's suppose if it is come out to be positive E plus E. When you put it here in the correct reading, it will be subtracted and the negative 0 error minus minus will become plus and it will be added automatically. It will be added automatically. Right? Sure. Let's try one question then. Alright guys, let's try this one. Very simple question. I'm very sure we can do it. No problem at all. Please go for it. Please go for it. So what does it say? It says the pitch and the number of division on the circular scale for a given screw gauge are 0.5 and 100 mm. Okay, very well. P is 0.5 clearly. Okay, and number of divisions on the circular scale, is 100. So let's calculate the least count. So it is 0.5 upon 100. So this is going to be how much? It is going to be 0.5 upon 100. So let it be like this. 0.5 upon 100 into in mm. When the screw gauge is fully tightened without any object. So without any object, that means it is the condition before the measurement. It is the condition before the measurement. So before measurement condition, the 0 on the circular scale lies 3 division below. 3 division below, that means it is positive 0 error. So we have positive 0 error. So what will be? So it is going to be least count into number of coinciding division. Okay, number of coinciding division. So on. We already know the formula. Na? So number of coinciding division with the baseline of the main scale. So what is this positive 0 error will come out to be? It will be least count, that is 0.5 upon 100 into 3. Okay, 0.5 upon 100 into 3. So this will be plus 0.5 into 3, that is 0.15. So 0.015 mm, right? 0.015 mm. Okay, it will be 0.015 mm, right? So we have this positive 0 error. We have this positive 0 error, isn't it? Just I'll check. So this is going to be 0.015 mm. So we have this positive zero error. So now when we have this positive zero error, so now we have to find the thickness of the sheet. So for that, we first have to get the reading in the normal way. So what is the total reading? So it is written the reading on the main scale is 5.5. So the reading on the main scale is 5.5 and the circular scale is 48. So least count into 48 reading on the circular scale. So this will become 5.5 plus least count. Least count is 0.5 by 100 into 48. So from here we are getting 5.740 mm. This is your true reading. This is your total reading or the reading from the screw gauge, but there is some zero error. So how to take care of the zero error? So that is when we are going to find the correct reading. So what is the correct reading, guys? What is the correct reading? It is the total reading minus zero error. Zero error is always to be subtracted. Sorry. Zero error is always to be subtracted. So zero error is always to be subtracted. We have 5.740 minus the zero error. So the zero error is 0.015 mm. So from here we are going to get obviously this 5.725 m, right? Okay. Okay, so the option is B. Right. So guys, in this session, we have completed the screw gauge completely. We have seen all the concepts of the screw gauge. I hope you have enjoyed this session. Okay. And with this session, this first chapter of units and measurement is also completed. Okay. It's also completed. So I'm going to come up with one more session. In that session, I'll give you the complete revision of this first chapter in one go. Okay. Okay, so it will be, I'll be covering everything. So in these sessions, we have covered everything in very much detail. In the marathon session, I'll be little quick. I'll be concentrating on the concept and I'll give you the whole reason of whatever we have learned. Okay, so if you are following me, if you are watching these sessions, and if you feel that there is a requirement of revision, so in that session, you will get a quick revision to each and every concept that we have learned till now. Okay. Okay. So guys, I'll keep it to this point. Don't forget to subscribe to your very own channel, NEET Success Simplified. And I'll be looking forward to see you in the next session. And after that, we'll be starting with the next chapter. That is the chapter of kinematics. Okay. So with this, thank you very much. Have a good day. We'll see you in the next session.